All right. In fact, just one request: if from next time onwards, if one of you remembers at the beginning of class, just try to remind me to start the recording. Okay, sometimes I may forget. So just at least one of you take the initiative. In the beginning of class, just remind me to start the recording. All right. Okay. So angle and radians. So this is now a new unit of measuring angles. In fact, this is what is going to be the SI unit by which angles are measured. Let's see how this unit is defined. Now you have some idea of how angle in degrees is, or you have some perception for angle in degrees. You know what 90 degrees looks like, you know what 360 degrees, 180 degrees looks like. Okay, this is another unit for angle, and this is defined by this formula. So it's defined as arc length by radius. All right, so imagine that I have these two lines जिसके बीच में मुझे angle चाहिए. So what we'll do is we'll try to keep the lines of the same length, and we'll try to draw a circular arc like this. That's my circular arc. So we'll try to draw that circular arc. अगर वो arc का length है S, और अगर ये radius line का length is R, then angle and radiance is defined as S by R. It's defined as arc length by radius. Okay, that's the definition. His definition say, have a look at this example. Okay, so what does 180 degrees look like? In fact, what does 180 degrees look like in radians? So if I were to draw an arc between these two lines, this would be the arc that I have to draw. Okay, now that arc's length, this is now the length of a semicircle. So instead of 2 pi r, this is going to be pi r. So the arc's length is pi r, the radius is r. When I divide the arc length by the radius, what do I get? I get pi r by r. R katega. I get pi radians. So 180 degrees is pi radians. Got it? And that is maybe the one thing which you can also remember. Of course, you have to remember this definition. You also have to, of course, associate 180 degrees with pi. And if you associate 180 degrees with pi radians, you can use that by your unitary method to convert any angle in degrees to the corresponding angle in radians and vice versa. The only somewhat confusing thing about this is sometimes, I don't know why they do this, but यहाँ पे this unit radians need not be written. You'll often see in many cases they don't write the units. Okay, so I'll explain 180 degrees again. ये straight line है, दो ऐसा straight line के बीच में angle 180 degrees है. हम वही angle radians में कैसे measure करेंगे? तो वो दो straight lines के बीच में एक circular arc draw करेंगे, centered at this point. Circular arc draw करेंगे. वो arc का length measure करेंगे. That becomes our numerator. Arc length is our numerator. तो numerator हो गया pi r. Denominator हो जाएगा उस arc का radius. तो ये रेशियो क्या आएगा? सेमी सर्कुलर आर्क का लेंथ है पाई आर, रेडियस है आर, तो रेशियो हमेशा पाई आएगा. You take a smaller arc, circumference will be lesser, arc length will be lesser, radius will be lesser, but the ratio will always be pi. है ना? So 180 degrees के लिए ये रेशियो हमेशा पाई आता है. And that is the way angle and radiance is defined. So angle and radiance in this case is pi radians. ठीक है? And यहाँ पे the tricky thing is sometimes you may find people write RAD for radians, but almost 99% of the time you'll find people don't write any unit for radians. It's one of those places where the unit is implied. If we are talking about angle, and if no unit is mentioned, we are talking about angle in radians. Okay? So just copy this. I'll of course explain more on the next page. इसमें कुछ doubt है? Okay. Uh, why is the unit not written like other quantities? It's just convention. It's just convention. I mean, it's always implied. तो स्टार्टिंग में थोड़ा ऐसा बिजार लगेगा, बट एज यू कीप डूइंग दिस, बाद में तुम्हें भी ऐसा आदत जैसा हो जाएगा. सो इट्स जस्ट इम्प्लाइड. Therefore the unit is normally skipped. It's just the convention. Others do it, we are also doing it. Okay? For to start with, I may you may see me write a little bit of this, so that it's very clear that we are talking about angle and radians. But eventually, you'll find me drop this as well. Okay, radians means का बात नहीं है. Radians is a unit defined this way. Radians is nothing to do with the arc. एक चीज समझो, देखो, radians is the a way of measuring angle. Okay, I can find radians. हाँ, अच्छा एक मिनट, एक सेकंड. One of you is saying, sir, if we find angle in pi, does that mean we assume it to be in radians? Yes. Moreover, if you find angle without degrees mentioned, you should assume radians. ठीक है? Unless there is an obvious typing error, if you find angle without degrees mentioned, you should assume radians. ये भी अगर देखा ना sin 30, technically अगर तुमने sin 30 देखा है ना, this is not half. The degrees should be there. When degrees is there, it's equal to half. When the degrees is not there, it's not half. Okay? This rule of radians is used for all angle. मतलब क्या है? Angle तो एक ही चीज होता है. A plane angle, well, the angle you've learned in school, the angle you have measured. अच्छा, do you mean across all degrees? Yes. कोई भी angle in degrees can be converted into angle in radians. ठीक है? This is the formula. We'll also see how to convert them. But just to answer someone's doubt, uh, it is not defined for a specific arc. I can have two random lines. ये इधर जो कॉर्नर है उसका मुझे एंगल अगर मेजर करना है, तो मैं खुद से कुछ भी आर्क ड्रॉ कर सकता हूँ. Any arc according to my convenience. That arc should definitely be centered at this point. If that arc's length is S, that arc's radius is R, angle will be defined as वो arc length by वो radius. और ये रेशियो हमेशा सेम आएगा. छोटा एंगल ले लो, बड़ा एंगल ले लो, वो रेशियो हमेशा सेम आएगा. ओके, so it's not limited to one specific arc. RAD is radians. Yes. uh, yes, Girish, yes. The angle should be actually the measure of the arc by central angle theorem. I have to check that. क्या ये central? Something you learn in school, right? Yeah, this is completely unrelated. How is that related? You know, thing I don't know it by name. Nudges. I think that's the theorem which says that the beach wall angle is double the angle on the major arc. That has nothing to do with this. Absolutely nothing to do with this. This is a way of measuring the angle. The whole idea is, and the way you measure that angle is defined by this formula. This has no connection with this theorem. Okay, simple. You draw the arc length and you find the arc, draw the arc, measure its length divided by radius. That ratio will always be fixed for a particular angle. The ratio is angle in radians. Okay, आगे और समझ में आएगा. Are you done with this page? See, it's just a new unit. It's just a new unit. In fact, this is, you'll find key. This will be the more important unit. How to measure the length of the arc. तुम इस ये actually to be honest, you can actually measure any arc length. ठीक है, ये जैसे for instance, before showing you what's written there, अगर मैंने ऐसा arc ऐसा बताया कि मान लो मैंने बता दिया कि ये 45 degrees है. If you know your geometry, you can actually measure arc length. Can somebody help me with this? क्या हो जाएगा 45 degrees? Like starting fresh, तुम 180 degrees इस पाई से भी ये निकाल सकते हो. But if you're starting fresh, what would be the length of this arc? जिसका radius is r, जिसका angle है 45 degrees. Yes, Saloni Kainat, सही है. Yeah, you're giving me the angle. Very nice. Okay, so this 45 degrees is 1/8 of 360 degrees. 360 by 8 is 45. So if the total length is 2 pi r, this length becomes 2 pi r by 8. Okay, and then when I divide r and r cancels, so the angle becomes pi by 4. So 45 degrees is pi by 4. So the question I was trying to answer was, how do we measure arc length? You can easily measure arc length because you know that 360 degrees is 2 pi r. So by unitary method, arc length measure करना always आसान है. अब ये नहीं कि मैं तुम्हें हर बार है ना ऐसा ड्रॉ सर्कल ड्रॉ वगैरह करवा के डिवाइड करवा के I'll make you convert angle in degrees to radians. Now you can just simply apply your unitary method. Okay, so pi is 180 degrees. We know that. So because pi is 180 degrees, by the way, somebody is asking what is the difference between pi is 3.14 and pi is 180 degrees. Yeah, pi is an irrational number. मतलब पाई को तुम लिखने जाओगे तो यू विल हैव 3.1428 नेवर एंडिंग सीक्वेंस. उसको जब हम राउंड ऑफ करते हैं तो 3.14 दिखता है. तो पाई तो इज ऑलवेज 3.14. दैट इज नॉट अ डाउट. पाई का वैल्यू क्या है? पाई इज अ वे टू रिप्रेजेंट दैट कॉम्प्लेक्स नंबर. पाई देखोगे तो इट इज 3.1428 समथिंग 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 समथिंग. We are telling you कि pi radians, यहाँ पे whenever we talk of angle, what is implied but not always written is radians. So pi radians या 3.14 radians approximately is 180 degrees. I'm not saying the number pi is 180 degrees. I'm saying the angle in radians pi, that is 180 degrees. Okay, but we are not always going to write angle in radians, so get used to that. ठीक है, whenever we are talking about angle, get used to not seeing radians written. And if radians is not written, unit is not written, understand it is angle in radians. अब देखो कैसे कन्वर्ट करेंगे, बहुत सिंपल सा तरीका है. पहले तो यूनिटरी मेथड से look at all your standard angles. If pi is 180, 2 pi is 360, right? Pi by 2 is 90. Okay, familiarize yourself with that. Pi by 2 90. फिर 3 pi by 2 मतलब pi plus pi by 2 है ना. 3 pi by 2 is 180 plus 90, 270 degrees. फिर pi by 2 को और डिवाइड कर लो. Pi by 4 as we just saw becomes 45 degrees. 180 को 4 से डिवाइड किया, पाई को 4 से डिवाइड किया. फिर okay, again somebody saying without the unit. Baba, without the unit, it depends on the context. Somebody, like, if you remember the homework question which we didn't discuss yesterday, the homework question was the angle between those two vectors is 2 pi by n. The angle between the two vectors is 2 pi by n. They're talking about angle. Unit कुछ दिया नहीं है. So then we understand कि this is not 2 into 3 point, I mean, of course this 2 into 3.14 by n, but what is it? It's angle in radians. Okay, so यार, if your question is, sir, can I look at pi and think of 3.14, who's stopping you? Pi is close to 3.14. वो तो है ही नहीं, वो तो कोई डिनाई कर ही नहीं रहा है. Pi is an irrational number. उसका approximate value is 3.14. उसका approximate value is 22/7. वो तो डिनाई कर ही नहीं रहा है. ऐसा नहीं कि do I have to choose between over here, do I have to choose between 180 degrees or 3? This is always approximately 3.14. That's never a doubt. Point is, if we are talking about pi radians, if you're talking about angle and we see pi n, we'll, in general, if you're talking about any angle without the units, we'll be talking about that angle in radians. So pi radians is 180 degrees. Like 2 radians will be some weird angle in degrees. वैसा 3.14 radians happens to be a nice angle in degrees. Happens to be exactly 180 degrees. ठीक है? 3.14 के लिए नहीं, pi exactly 180 degrees होगा, 3.14 approximately 180 degrees होगा. ठीक है? Did that clear your doubt? Let me know. हाँ, 3 pi by 4. So this is 75% of pi. So this will be 135 degrees, है ना? Or you can add these two, pi by 2 and pi by 4 को add कर लो. So 3 pi by 4 is 130 degrees. These ones, please, है ना, be very, मतलब ये pi by 3, 180 by 3, 60. तो pi by 3 देखते ही you should remember 60 degrees. और 60 degrees देखते ही you should remember pi by 3. 2 pi by 3 देखते ही you should remember 120. Okay? 60 का डबल. फिर 60 को और डिवाइड किया 2 से, तो pi by 6 is 30 degrees, and then pi minus this is 180 minus 30, so 150. So मेरे यहाँ पे जो लेफ्ट हैंड एक ऐसे कॉलम में मैंने जो लिखा है, those are things which should, है ना, which you should more or less see without any calculation. स्टार्टिंग में तुम कैलकुलेट वगैरह करोगे, मन में डिवाइड करोगे by 3 वगैरह, but eventually you want to do this so often that in fact you will be doing this so often that you'll want to remember these values. So starting with, just make a little effort to memorize 45 is pi by 4 वगैरह, and eventually है ना, you'll see that you'll be using them so often कि ऐसे ही subconsciously pi by 4 45 तुम करोगे, कैलकुलेट करने का जरूरत नहीं पड़ेगा. ठीक है? अब फिर भी अगर कैलकुलेट कुछ और केस में अगर कैलकुलेट करने का जरूरत पड़ेगा, so then this is your, what's in green is your formula. So what is in green? If I go from x degrees and I want to write the same value in radians, okay, so I multiply x degrees with pi radians and I divide by 180 degrees. Degrees कटेगा. So x into pi by 180 is the formula for radians. है ना? x into pi by 180 is the formula for radians. ये कैसे किया एक बार समझो. मैंने ऊपर नीचे सेम चीज से मल्टीप्लाई डिवाइड किया. You are always allowed to multiply and divide with the same number. अब denominator I divided by degrees, 180 degrees. Numerator I multiplied by pi radians. Okay, and when I do that, degrees and degrees cancels out. So what am I left with? I'm left with x pi by 180 radians. That's how you convert from degrees to radians. इतना मन में रखो कि या तो पाई बाय 180 से मल्टीप्लाई करना है या 180 बाय पाई से मल्टीप्लाई करना है. रेडियंस वाला आंसर, हाँ देखो ये फाइनल ऐसे याद रखो. या तो पाई बाय 180 से मल्टीप्लाई करना है या 180 बाय पाई से मल्टीप्लाई करना है. रेडियंस वाला आंसर हमेशा छोटा दिखता है ना. क्लियरली द डिग्रीज वाला आंसर इज bigger. The degrees wala number is bigger. Radians wala number looks smaller. So if you want to get the value in radians, multiply by the smaller fraction. Multiply by pi by 180. Whereas if you want to go from radians to degrees, multiply by 180 by pi. You want to go from radians to degrees, multiply by 180 by pi. That's the way you can remember this. And कोई पूछता है सर इधर ये मैं कैंसिल करूंगा तो क्या आएगा. देखो पाई रेडियंस और 180 कैंसिल नहीं होएगा. कैंसिल करने के लिए क्या करना पड़ेगा. इधर अगर डिग्रीज है तब कैंसिल होगा. एंड व्हाट हैव यू अचीव्ड बाय कैंसिल पाई रेडियंस एंड 180 डिग्रीज. यू सेइंग x डिग्रीज इज x डिग्रीज. मैंने सवाल दिया, तुमने सवाल वापस आंसर किया. There's no doubt that the question is equal to the question, but we want the answer. We want to convert this to radians. ठीक है, कैंसिल मत करो. ठीक है, लॉजिक क्या था. लॉजिक था we multiplied and divided with the same number, not so that we can cancel again and go back to the question. We multiplied and divided by the same number because we are allowed to do that first and foremost, and we intentionally put degrees down. Okay, I'm multiplying and dividing x degrees by the same number. I'm repeating for you. Pi radians is up, 180 degrees is down. Degrees cancels out. And what is left? Radians is left as my unit. So x degrees becomes this number in radians. So x degrees becomes x pi by 180 radians. Okay, I'm just showing you the logic for unit conversion. This is how you can approach any unit conversion. ये वाला भी एक बार जैसा देख लो. Pi radians. So what will I do? Okay, so y radians को अगर मुझे convert करना है, I will again multiply divide by the same number. Okay, तो अब यहाँ पे मैंने लिखा नहीं है, but let's say this is y radians, और मैं नीचे pi radians से divide करूंगा ताकि रेडियन कट जाए. अब नीचे पाई रेडियन से डिवाइड किया तो ऊपर भी सेम चीज से मल्टीप्लाई करना चाहिए. तो ऊपर में किससे मल्टीप्लाई कर रहा हूँ, 180 डिग्री से मल्टीप्लाई कर रहा हूँ, which is the same. But writing it in this manner has cancelled out radians as the unit and has left me with degrees as the unit. Proving pi radians is pi 180. क्या बोल रहा हूँ, y radians is y 180 by pi degrees. So just to give you an example, अगर मुझे 37 डिग्रीज कभी रेडियन में कन्वर्ट करने का जरूरत पड़ेगा तो व्हाट विल आई डू. आई यूज दिस फॉर्मूला. सोचूंगा अच्छा डिग्रीज से रेडियन जा रहा हूँ, रेडियन नंबर वाला छोटा रहता है, रेडियन वाला नंबर छोटा रहता है, तो मैं छोटे फ्रैक्शन से मल्टीप्लाई करूंगा. दैट्स हाउ यू कैन रिमेंबर. तो 37 को पाई बाई 180 छोटा नंबर में बड़ा नंबर से मल्टीप्लाई करूंगा. आई विल गेट द करस्पॉन्डिंग वैल्यू इन रेडियंस. So 37 degrees is 37 pi by 180 radians. What about 2 radians? If I want to convert from radians to degrees, okay, again for your convenience I'm explicitly writing this. आगे we won't do that. But 2 radians को convert करना है तो क्या करूंगा? I'll multiply this with 180 by pi. I'm going to degrees. So I'll multiply it with 180 by pi. Okay. So I'll multiply it with 180 by pi. So this becomes 360 degrees by pi. Okay. Let me just see your doubts. So pi is in radians, 180 is in degrees. They're different units. So how did you multiply y with 180 degrees? अरे यार पहले do you agree with this statement? You agree with this? Do you agree कि I can multiply any number? कुछ भी. I can multiply it with any. If I multiply something and divide it by the same number, I do not change my number. Do you agree with that? I have a specific quantity now. I have this quantity y radians. I am multiplying y radians with some number and dividing by the same number. Is there anything wrong in that? Nothing wrong in this. But now मेरा क्यों कर रहा है ना? There's a reason for doing this. ऐसे मजा मजा नहीं आ रहा है. I'm doing it for a reason. I am deliberately going to write now, again using this, I'm going to write 180 degrees as pi radians. So that radians cancels out and I get degrees as my remaining unit. मतलब pi radians is now pi 180. क्या बोल रहा है यार? Y radians is now y 180 by pi degrees. That's how we converted this. Okay. Okay. And you don't need to calculate arc length anymore. You have to use this conversion. Use this conversion and use these standard values to get radians. You don't have to calculate arc length. Ulta, we'll be doing vice versa. We'll use angle in radians to calculate arc length. Okay? Please don't calculate arc length. वो मैंने ऐसा demonstrate किया. You don't have to calculate arc length like that. We will be using angle in radians to calculate arc length. मुझे अगर angle in radians पता है 3, arc length बोलेंगे r into 3. Arc length is radius into theta. Theta is s by r, so s is r theta. So later on, as we proceed, you'll find we use angle and radians to calculate our arc length. Okay, done. All pending doubts gone. Okay, यहाँ पे this is 1 3. ज़्यादा confuse मत हो जाओ यार. The number pi is something close to 3.14. पाई का कुछ 180 नंबर से संबंध नहीं है. जिधर भी तुम पाई देखोगे तुम 180 घुसाओगे नहीं उधर. But pi radians is 180 degrees. Okay, यहाँ पे of course this is 360 by the number pi. इसको तुम है ना जबरदस्ती इधर 180 मत डाल दो. तुम 180 degrees डाल के you can go back to 2. 360 degrees by 180 degrees लिख के you can go back to 2. है ना? And when we're talking about angle, just 2 means 2 radians. But then you're back where you started. Pi 180 degrees डालोगे तो you'll get back this question. To proceed further, you'll keep it as pi. Got it? यहाँ पे pi radians को 180 डाल दे, you'll get 37 degrees. It's not wrong. It's not wrong, but you've not done anything. You're back where you started. Okay. No doubts in that. Okay, that was. Why should it always be in fraction pattern? What should always be in fraction pattern? कटना है तो कट भी सकता है ना, 60 डिग्रीज इज 60/180 पाई/3 हो जाएगा, या 360/180 उधर 2 पाई हो जाएगा, उधर फ्रैक्शन नहीं दिख रहा है। बेसिक फॉर्मूला x and 180 can have common terms and cancel out as well. Okay, done. All right, so that was just a brief intro into angle and radians. We'll of course, as we start using it, you'll get more and more comfortable with it. Okay, so page 3 you don't need to copy. I think I'm just revising parallelogram's law before we proceed, so you don't need to copy this. We just saw this recently, but one of the things we like about this law is we get to see angle, we get to see the sum, we get to see the difference, we get to see all of this in the same diagram. Okay, all right, so moving on to slide 4 then. Unit vectors. What are unit vectors? Okay, so these are vectors having unit magnitude. All right, so there's a common word used in physics. Whenever you see the word unit magnitude, we normally imply 1. Okay, so unit magnitude means magnitude equal to 1. Let's zoom in a bit. So they are vectors having unit magnitude equal to 1. They are represented by a cap over the symbol. They are represented by a cap. So this icon, okay, this symbol over the alphabet. That's how they are represented. So instead of a bar, these guys have a cap. Okay, and to find a unit vector parallel to another vector, we will divide the vector by its magnitude. So I'll explain that. We'll divide the vector by its magnitude. First and foremost, symbol ऐसा दिखेगा. This is A cap. How do you read this? This is A cap. This is B cap. Okay, that's how it's read. Okay, and you place that roof type symbol over the alphabet. If I want a unit vector parallel to vector B bar, so unit vector parallel to vector B bar will be represented as B cap. ठीक है, B bar का corresponding unit vector या B bar के parallel unit vector will be B cap. Okay, so for instance, if B bar is 7 Newton upward, B cap will be just 1 upward, not even 1 Newton, just 1. Okay, magnitude is equal to 1. So, magnitude is not just a number. The number and the unit are replaced with 1. So, B cap will be just 1 upward. Okay. Now, if you look at this example, in this example, I try to explain 1 upwards. ये vector हो गया. B cap is 1 upwards. Means का बात नहीं. This is 1 upwards. That's a vector. It has magnitude 1. It has some direction. So that is our unit vector. Any vector with this magnitude is a unit vector. Okay. Any vector with just magnitude 1, no units, just 1, that is a unit vector. So to get a unit vector parallel to this guy, I'll represent it actually with the symbol B cap. And what will that be? There'll be a vector of magnitude 1 in the same direction as B bar. Okay. Now, इसका यूज वगैरह तुम्हें आगे दिखेगा. फिलहाल I can just say it's a good way to capture the direction without capturing the magnitude. है ना? We know कि magnitude is very well captured by taking the mod or by removing the bar. But how do we capture the direction? B cap is good at capturing the direction. B cap describes the direction without describing the magnitude. So that's just a glimpse. आगे देखेंगे इसका यूज. बट अब यहाँ पे मैंने एक लाइन बोला था कि यूनिट वेक्टर निकालने के लिए इनफैक्ट पैरेलल टू अनदर वेक्टर, मतलब बी कैप इस केस में निकालने के लिए, I will divide the vector by its magnitude. I will divide the vector by its magnitude. So if you look at this example, I've taken an example where B bar is 5 Newton. If B bar is 5 Newton, magnitude of B bar is 5 Newton towards right. Magnitude of B is only the number 5 Newton. Okay, only the value 5 Newton. What will I get if I divide B bar with its magnitude? The claim is ये करके B cap मिलता है, वेक्टर को उसके मैग्नीट्यूड से डिवाइड करके बी कैप मिलता है. तो देखो वेक्टर था 5 न्यूटन टुवर्ड्स राइट, मैग्नीट्यूड था 5 न्यूटन. सो 5 न्यूटन टुवर्ड्स राइट अपॉन 5 न्यूटन will have 5 Newton cancel out, and won't I be left with 1 towards right? So isn't this formula correct? Doesn't the formula now make sense? To get the unit vector, I had to take out the magnitude. Matlab I have to divide the vector with its magnitude. And I end up getting, when you divide them with the magnitude, magnitude is not just 5, it's 5 Newton. So when I divide 5 Newton towards right with 5 Newton, I'm left with 1 towards right. That is my unit vector. Not 1 Newton towards right, 1 towards right. Okay, no units. That is my unit vector. So this therefore is the general formula for finding your unit vector. To find the unit vector along any other vector, divide the vector by its magnitude, and that's an important formula. यहाँ पे फिलहाल उसके यूज बहुत सिंपल लग रहा है. As we learn further, है ना, this formula will become an important formula to use. Any doubts in this page? Okay. Done. Anyone is saying wait? Can we add unit vector to other normal vectors? So you can actually add two vectors, but the point is you can't add two different physical quantities. So you can't add force to speed, velocity. That makes no sense. Adding force to velocity makes no sense. You can only add force to force. Okay, so I can't add this unit vector to force, a force vector, but I can definitely add this unit vector to another non-unit based, and I can add 1 towards right to 3 upwards. 3 upwards is also a vector. It doesn't have to just be a physical quantity. Vectors is maths. Any number followed by a given with a direction that can, in a way, represent a vector. So it can be added to other vectors of the same type. It should not have any units. Okay. Yes, of course, it's a vector. It will follow triangle law and all that. Yeah, but itna dhyan rakho, and a unit vector does not have any units. Yes, so you don't write a unit after the unit vector. Absolutely. And what is the use of unit vector? भाई थोड़ा आगे दिखेगा. Okay, आगे दिखेगा. What is the use? इतना मतलब अब तो आइडिया भी बता दिया है ना, वो आगे दिखेगा. What is the use of it? Okay. And just again, somebody asked again, does it follow triangle law? Yes, it's a vector. It follows triangle law. So this unit vector 1 plus this unit vector 1 will give me root 2. Yeah, so it does follow triangle law. It's like any other vector. It only has a specific magnitude. It has a predefined magnitude. It can have any specific direction depending on the context. But as long as it has magnitude 1, it's a unit vector. It's just a type of vector. Now, there are some special unit vectors, okay, which are given special names, which are reserved with some special names. So, what are those special unit vectors? So, unit vector parallel to the x-axis is always represented by I cap. Okay, and now watch out for this. I cap, the way you write I cap is, because I already has that dot over there, we get rid of that dot and we write the cap in place of the dot. Yeah, that's just convention. We never write it this way. We'll get rid of the dot and we write the cap in place of the dot. So that vector I cap represents a unit vector along our x-axis, along our positive x-axis. Okay, I cap ऐसा हो गया. Then a unit vector parallel to our parallel to our y-axis is represented by j cap. I के बाद आता है j, x के बाद y, I के बाद j. So this vector parallel to our y-axis, positive y-axis, is represented by j cap. Okay, and j cap could be, since j normally had a dot over it, the way we write j cap, these are all small alphabets. Okay, small I, small j, small k. The way we write j cap is, instead of the dot, we'll place the cap. Instead of the dot, we'll place the cap. Yeah, so you'll not see a symbol like this. Instead of the dot, we place the cap. That's j cap. And then parallel to the z axis, is it? I think sometimes, this is the most common convention, but then sometimes, depending on the limitations of whoever's printing, yeah, they can end up maybe putting the dot as well. It depends on how they format the text. If they have a special symbol for this, they'll use this. Otherwise, sometimes they may create a symbol where the original alphabet just has a cap on top of that. So it depends on the context. Yes. So take it fine. Don't be very rigid. You could, apparently NCRT has used this, so you could see that symbol as well. Yeah, but wherever possible, you'd find this is typically more common. Either way, you see I with something like a cap, okay, that's going to represent a vector along the x. J with something like a cap will represent vector along y. And finally, K with a cap, okay, will represent a vector along the unit vector along the z axis. So with this, we now have special names for these 3 unit vectors, I cap, j cap, and k cap. But then, as you can see, with this information, we can start to write other vectors as well. Okay, so here we're going to get to see the use of unit vectors. For instance, I can say this vector, one opposite my x-axis, one towards the negative x-axis, that is minus I cap, because that is opposite I cap. Similarly, one opposite y, that gets the name minus j cap, because that's opposite positive j cap. Similarly, one opposite my z-axis, this guy, gets the name minus k cap. Okay, so all of a sudden, instead of 3 vectors, now we have 6 unique names. I cap, minus I cap, j, minus j, k, minus k, which represent accordingly unit vectors along x, negative x, y, negative y, z, negative z. Okay, अब देखो इन 6 वेक्टर से what more can we do? मान लो मुझे ये वेक्टर को एक और तरीके से लिखना है. ये क्या है? 2 न्यूटन टुवर्ड्स राइट, है ना? So imagine if I want to draw this in another way, represent this in another way. So I can say कि 2 Newton towards right is actually 2 Newton, the number, the magnitude 2 Newton into 1 towards right. No problem. इनको multiply करेंगे तो ये आ जाएगा. Multiplication of a vector with a scalar से. The 2 Newton towards right is 2 Newton into 1 towards right. And what is 1 towards right? Isn't 1 towards right I cap? So suddenly I have found another way of expressing this vector. So instead of drawing that arrow and saying it's 2 Newton, I can even just say 2 Newton I cap, and that becomes a way for me to represent that vector. Yeah? Why don't you try? How would I represent 3 meters per second going in a direction opposite to my z-axis? How would I represent 3 meters per second going opposite to my z-axis? How would I draw that? Yeah, very nice. Okay, cool. Just don't miss out the units. Okay, so the answer will be माइनस z कैप नहीं है ना, z के करस्पॉन्डिंग k कैप है, x के करस्पॉन्डिंग i कैप, j के करस्पॉन्डिंग y कैप, z के करस्पॉन्डिंग k कैप. So the idea will be, what you'll do, you'll say, अच्छा, this is 3 meters per second into my unit vector along negative z. So it will be 3 meters per second into 1 along that direction. 1 along that direction becomes minus k cap. If some of you didn't write meters per second, remember it's not 1 meter per second along the direction becomes minus k cap. It's 1 along that direction which becomes minus k cap. So I still have to write the number and the complete units in front of that. So it's 3 meters per second into minus k cap. Yeah, minus 3 meters per second k cap. Okay. So filal, it's helping me write vectors along these lines. Okay. It's helping me write vectors along the x, y, and z axis. Any vector with any units along the x, y, and z axis can now be written in a new form where we use I cap, j cap, and k cap. That form has a name. We'll see that name in some time. Okay, but first we'll continue to develop this idea a little bit more. Let me know when you're done writing, and let me ask me any doubts if you have. Smriti Rupa, yes, that is if it is implied or told ki Z is perpendicular to your screen, then yes. And can I explain why 3 is negative? 3 negative नहीं है, बात वापस इस पे आ रहा है. ये तो ये 3 meters per second in that direction is 3 meters per second into 1 in that direction. वहां पे कोई दिक्कत नहीं है. 1 in that direction is minus k cap, वो भी उसमें दिक्कत नहीं है. 1 opposite z is minus k cap. Then vector's name is minus k cap. Okay, and remember, for a vector, minus does not literally mean negative the way we imagine negative for numbers. You know, for us, when we imagine minus 3 and 3, we imagine minus 3 to be lesser than 3. Vectors में वैसा नहीं है. Minus k cap is not lesser than k cap. It's just a different direction than k cap. Okay, minus k cap is just the opposite direction of k cap. So then minus is not really negative the way we picture it. It just means the direction is opposite of whatever the vector is representing. So when I multiply minus k cap with 3 meters per second, I naturally end up with this. When you see this, you should not say, अरे why is 3 negative? वो negative जैसे तुम पिक्चर कर रहे हो है ही नहीं. माइनस साइन का एक काम है, माइनस साइन डायरेक्शन बताने के लिए उधर है वेक्टर्स की केस में माइनस साइन इज ओनली देयर फॉर द डायरेक्शन. It tells you कि the direction is opposite of whatever this vector is representing. Vector वाला part क्या था? K cap. The rest was actually a number. The main thing that was representing the direction was K cap. Minus is there to tell you कि the direction is not K cap, not along Z, but opposite Z. अब समझा? Clear है अभी? है ना? So don't look at these minus signs in vectors and picture something negative. Okay? Now for the last time, guys, why is Z axis needed? Baba, Z axis, we live in a 3D world. We're not living in the plane of a paper. You know? We live in a 3D world. Any object you see is they're all three-dimensional. Nothing is like a square plate only. You know? Even a square plate, even a cheese slice has some thickness. So we live in a 3D world. So of course, we want maths to model the 3D world. Yeah? So X, Y, Z का भी of course जरूरत है. Everything that we're going to study in physics is possible in X, Y, and Z axis. Is possible in 3 dimensions. Okay. How do we normally how had I represented Z earlier? I had represented it by I had represented vectors coming out of the plane with this kind of arrow, with that kind of symbol. So that represents your vector coming out of the plane, or that can represent a direction coming out of the plane. ठीक है. इसी को अगर मैं दूसरे एंगल से देखूंगा तो I'll have to draw it like this. So this is it's when I draw something like this, I'm not saying that they're all in the same plane. This is just a 2D rendering, a 2D drawing of something which is three-dimensional. If you look at the corner of your room right now, find a corner and look at it. Okay? Try to look at a corner which is in front of you towards your left. Aren't you seeing this? If you look at a corner right now, the corner of your room, you're going to see this. Does it mean that this line, and this line are all in the same plane? Does it mean that this wall, and this wall are all in the same plane? No, they're all different planes. The 3 different planes. And these lines are along 3. In fact, these 3 lines are mutually perpendicular. सब एक दूसरे के साथ 90 डिग्री वाले एंगल पे है. ध्यान से देखो. Everything is perpendicular to the other. If you live in if of course your house is like normal houses, all angles will be 90. So these lines are perpendicular to each other, mutually perpendicular, आपस में perpendicular. इसको बस render किया है 2D में. So whenever you draw a diagram like this, that's just a rendering. That's just a way of drawing something which is 3-dimensional in 2 dimensions. My goodness, मैं अभी बोल रहा हूँ, the diagram does not represent coplanar vectors. यार, एक मिनट. Guys, you see this corner over here? Can you see this line? This line is vertical, this is horizontal, this is horizontal. Can you see that these two are perpendicular? Then this and this is perpendicular, this and this is perpendicular. Call this your x-axis, call this your y-axis, call this your z-axis. We don't want to spend our entire class over here. How do I draw this on a piece of paper? So to draw this x, y, and z, to draw these perpendicular directions, 3 perpendicular directions, on a piece of paper. To do that, I'll have to do some kind of rendering. I'll have to represent. I am. My screen is not three-dimensional. Your screen is also not three-dimensional. What you're looking at is a two-dimensional screen. So the way we draw that and still in a way try to show that this is a three-dimensional object. So this is the way we draw that. Okay. Draw correct 2D screen, but we are representing something three-dimensional. Okay. Even what you see on TV, it's all you're seeing movies capturing events which are taking place in 3D space. When you see a painting, you are able to understand the mountains are behind and houses are close by. You're able to understand all of that. It's done in a 2D place. It's just the way it has been rendered and the way your brain works. You understand something is far off, something is close by. So I say, I want you to understand this. Whenever you see a diagram like this, don't think it's three vectors in the same plane. Okay, I'm trying to draw X, Y, and Z axis. I'm trying to draw three mutually perpendicular vectors. Okay, the lines you see in the corner of your room, I'm trying to draw that in one plane. Okay, got it? Clear with this? Yes. Okay, and if an object, these planes have names also. जो X और Y वाला है ना, ये वाला जो wall है, X और Y के बीच में, that's called the XY plane. In your school, you spent a lot of time with this. Okay, this is called as the YZ plane. This is called as the XZ plane. So the floor in that case will be the XZ plane. The left wala wall will be the YZ plane. सामने wala wall will be the XY plane. ठीक है? All right. So आगे बढ़ते हैं. All right. इतना ही है क्या ये पेज पे? Okay. On this page, I just want you to agree with me कि if I have this blue vector, okay, मान लो I have this blue vector. ये मेरा blue vector is my main focus. Okay. ये ब्लू वेक्टर को मुझे एक दूसरे तरीके से लिखना है. अब ब्लू वेक्टर क्या है? ये ना ही x के अलोंग है ना ही y के अलोंग है. दिस इज अलोंग सम डिफरेंट काइंड ऑफ डायरेक्शन. ठीक है, इट्स नाइदर अलोंग x nor along y. Okay, but I have learned to write any vector along x and y in this interesting format. यहाँ पे देखा, on this page we are now able to write any vector along x, y, and z in a new format. I'm curious to see how can I write this vector which is neither along x nor along y. How do I start writing that also in the same format? तो उसके लिए what we're going to do is we are going to say कि अरे ये जो blue vector है वो तो बाय ट्रायंगल लॉ हम प्रूव कर सकते हैं कि इट्स द पिंक वेक्टर प्लस द येलो वेक्टर. डू यू अग्री विद दैट? मतलब आई कैन रिप्लेस माय ब्लू वेक्टर. यस, आई कैन रिप्लेस माय ब्लू वेक्टर विथ this pink vector and this yellow vector. So if my blue vector is, yes, if my blue vector is some vector in the xy plane, I can replace it with a vector along the x-axis and a vector along the y-axis by triangle law. Why will we do this? We'll see. Okay, the hint is this is going to make addition easy. This is going to make addition of any random vectors easy. That is why we're going to do it. How does that work out? कुछ देर में दिखेगा. ठीक है, बट फिलहाल आई कैन रिप्लेस द ब्लू वेक्टर विद द पिंक एंड द येलो वेक्टर. ठीक है, आई एम श्योर यू गाइस हैव कॉपी दिस. कोई वेट बोल रहा है? चलो यार जल्दी, 3 ही लाइन है. ठीक है, वेट बोलने वालों डन बोल दो होने पे. Okay, this is just triangle law. Okay. Abhi, with that, we're going to see how we will resolve. Okay, the title is Resolution of Vectors into Perpendicular Components. Resolution of vectors into perpendicular components. Come on. यार पहले अच्छा था. Resolution of vectors into perpendicular components. So first and foremost, what does the word component mean? So component just means part. The English word component means parts. So if I resolve a vector into components, I mean break it down to its individual parts. So in this case, we are saying that this, yeah, that's fine. We are saying that this vector, yeah, we are saying that this vector, the yellow vector, has two parts. Why am I saying it has two parts? Because by triangle law, we know that my yellow vector, in this case my f vector, is my x vector plus my y vector. So doesn't this become like the first part? Doesn't this become like the second part? And f is x plus y. So x and y are two parts of f. Another word for part is component. So x and y are two components of f. They are two things which make up f. Okay. So we want to see how to resolve f into these components. Means, yes, Girish. Yes. And it means we want to break f into these two parts. We want to break down f into these two parts, a part along the x-axis and a part along the y-axis. All right, to start with, we are going to keep z out of the picture. Z baad mein layenge. Filhal, we are focusing on x and y. Okay, keep it simple to start on a simpler note. Now, how do I resolve, how do I break f into x and y? So if you look at this, first and foremost, if let's say you have this angle theta, you can observe certain things. You can say cos theta is base adjacent by hypotenuse. So cos theta is x by f, magnitude wise. And sin theta is opposite by hypotenuse. So sin theta is y by f. ये साफ साफ दिख रहा है. Cos theta is x by f, sin theta is y by f. उससे देखो क्या मिल रहा है. उससे x का वैल्यू मिल जाएगा, y का वैल्यू मिल जाएगा. So if you look at this carefully, x becomes f cos theta in this case, y becomes f sin theta in this case. है ना? X has become f cos theta, y has become f sin theta. Now, इससे क्या हुआ है? I can now write my f vector, है ना? This vector f, which is making some angle with the horizontal. In fact, this is how we used to represent our vectors all this while. है ना? If I give you any question to solve and I would say add vectors, subtract vectors, तुम यही तो करते थे. तो मैग्नीट्यूड लिखते थे और हम ऐसा एक डायरेक्शन ड्रॉ करते थे और या तो हॉरिजॉन्टल लाइन या वर्टिकल लाइन के साथ एंगल रिप्रेजेंट करते थे. एंड समटाइम्स वी यूज्ड टू ट्राई सेइंग दिस इज so and so degrees north of east या नॉर्थ ईस्ट, ऐसा सब है ना बोलते थे. So we have so far been representing vectors with its magnitude and its angle with some simple line. यहाँ पे that same vector now is being written in terms of its horizontal and vertical components, matlab its horizontal and vertical parts. F, without a shadow of doubt, is F cos theta towards the right, this vector x towards right, F cos theta towards right, and F sin theta upwards, y upwards, yani ki F sin theta upwards. So F is definitely the addition of these two vectors. These are the two components of F, or the two parts of F. Moreover, based on what we saw on the previous page, this guy can be written as F cos theta into I cap, because this is along the x-axis. This one can be written as F sin theta into j cap, because that's exactly along the y-axis. So all of a sudden, I have now written this vector in this style, in a new style. I've written that vector somehow in terms of I cap and j cap. Girish, yes, we'll do that eventually. So we have written this vector in terms of I cap and j cap. All right. Now, I want you to this is just an example. Is say I want you to remember one thing. Don't remember कि the x component always has a cos theta in it. वो हमेशा true नहीं होगा. Rather, I want you to remember this. The component adjacent to theta, adjacent मतलब theta के बगल में. Out of the two components, isn't this the component adjacent to theta? है ना, ये theta के बगल में है. अच्छा, उसका वैल्यू कितना आ रहा है? ध्यान से देखो. The component adjacent to theta का वैल्यू आ रहा है hypotenuse cos theta. That is always true. So the component adjacent to theta will be hypotenuse into, that's into, okay, that's not x, hypotenuse into cos theta. So the component adjacent to theta is always hypotenuse cos theta. In this case, x was f cos theta. Similarly, the component opposite theta will always be hypotenuse sine theta. Y in this case is f sine theta. But with that we proved that the component opposite theta will always be hypotenuse sine theta. So this is going to be a general rule which we will apply आगे जाके भी. Component theta के बगल में, that gets to be hypotenuse cos theta. जो theta के opposite है, that gets to be hypotenuse sin theta. आगे थोड़े examples में तुम्हें समझ में आएगा. फिलहाल कोई doubt? Yes, Girish, yes. Okay. Can I explain the last part again? तो यहाँ पे ना ये जो हमने डिराइव किया है ना, इससे है ना cos थीटा sin थीटा के वैल्यू से हमें ऐसा कुछ रिलेशन मिला. अब ये रिलेशन को ऐसा याद मत करो कि x हमेशा cos होगा और y वाला कंपोनेंट हमेशा sin होगा, वो गलत है. उल्टा कैसे याद करना है, ऐसा याद करो कि जो कंपोनेंट थीटा के बगल में है, जो भी लाइन के साथ, ओके, जो भी ये एक्चुअली ये एक्स और वाई ड्रॉ क्यों किया, you can skip that. Yeah, even I am not, I think I just drew that to remind you कि this direction is actually I cap and this direction was parallel to y, therefore it's j cap. उसके ड्रॉ उस कारण के उसके वजह से ड्रॉ किया था. बट ओवर हियर कंपोनेंट adjacent to थीटा, जो थीटा के बगल में है ना, f जो लाइन के साथ थीटा बनाता है, उस लाइन के लॉन्ग कंपोनेंट, ये वाला पार्ट, थीटा के बगल वाला पार्ट, उसका वैल्यू हो जाता है हाइपोटेनस कॉस थीटा. और जो कंपोनेंट थीटा के ऑपोजिट होता है उसका वैल्यू होता है हाइपोटेनस साइन। हाँ, अगर कोई बोल रहा है साइन सामने कॉस चिपके हो, I post what this guy posted, what guy, this girl posted. So you can, if you want to refer to that. ठीक है, आई रिमेम्बर दिस वे, cos is adjacent by hypotenuse, तो cos and adjacent साथ साथ जाता है, sin is opposite by hypotenuse, sin और opposite साथ साथ जाता है। हाँ, ये x नहीं है, ये into है, ठीक है, ये बस कंफ्यूज मत हो जाओ, वो x नहीं है, वो into है, hypotenuse into cos theta, hypotenuse into sin theta. Okay, done with this page. Rajasri, that's something we'll do in the end of vectors, not right now. Okay, that's for later. It's good that you've read up though. Yes, Arushi, yes. वो yes. देखो अभी एग्जाम्पल देखते हैं, ठीक है, लेट्स लुक एट दिस एग्जाम्पल। अब ये एग्जाम्पल में है ना, ये स्टार्ट कैसे करना है, तो एक्चुअली यू स्टार्ट विथ दिस, लेट्स से दिस वाज आवर क्वेश्चन। ओके, मुझे ये वेक्टर, क्या है मेरा वेक्टर, 10 न्यूटन दिया है, एंगल दिया है, मैग्नीट्यूड दिया है, मतलब नाम दिया है 10 न्यूटन, एंगल विद वर्टिकल एंड द नेम। ठीक है, तो ये वेक्टर को मुझे आई कैप जे कैप के टर्म्स में लिखना है। ओके, नाउ अगेन if you are seeing me write it in this form, actually this is the reason why I drew the axes in the previous case as well. ये जब हम आई कैप जे कैप कभी भी, if they ask you to write in terms of I cap J cap ना, they'll normally have to specify the direction। ठीक है, ऐसा यूनिवर्सल नहीं है कि only right is x, that's not universally true। I can take this also as x, I can take this also as y, ऐसा नहीं है यूनिवर्सली कि only right is x, I can take the vector coming out of the plane as z। ठीक है, सो यूनिवर्सल नहीं होता है, जनरली होता है कि राइट एक्स की तरफ लेता है, मतलब एक्स को राइट की तरफ लेता है, बट इज नॉट यूनिवर्सली एक्सेप्टेड। इनफैक्ट व्हेनेवर योर एग्जाम विल expect you to write something in I cap J cap and they've just drawn a vector like this, they will definitely tell you take right as x, they'll definitely tell you take upwards as y। so है ना, ये एक्सिस के बारे में अगर बात करना है तो एक्सिस को डिफाइन करेंगे ही सवाल में। in a good question they will define the axis। so you know here I'm not just going to draw this and say write an I cap J cap, I will always tell you what the axes are। okay? And if I don't tell, I mean I imply this, but you know, a good question always the axes will be told to you। so x y, those are your axes, I'm taking right as x, I'm taking up as y। okay, now with that said, first task you will do is you will try to, this one I'll do as an example, you will try to figure out the vertical and the horizontal components। you can draw the same thing over here as well, कुछ है ना फर्क नहीं पड़ेगा, but I'm trying to figure out the vertical and the horizontal components। okay, तो पहले तो ट्राइंगल लॉ से तुम देखो कि अच्छा, पहले मैंने ये दो ड्रॉ किया, दो एक वर्टिकल लाइन ड्रॉ किया, हॉरिजॉन्टल लाइन ड्रॉ करके ऐसे राइट एंगल ट्राइंगल बनाया। दूसरी बात है, मैंने देखा कि 37 के बगल में जो है वो हो जाएगा हाइपोटेनस कॉस 37। तो लुक एट द नेम आई हैव गिवन दिस, द वैल्यू आई हैव गिवन दिस, हाइपोटेनस कॉस 37, 10 न्यूटन कॉस 37, adjacent is cos, opposite is sine। okay, so 10 newton sin 37 becomes this side का length, 10 न्यूटन sin 37 becomes that side का length। तो हमने लेंथ वगैरह ड्रॉ कर लिया। ओके, हाउ डू आई फिगर आउट द डायरेक्शन, ऑफ कोर्स cos 37 sin 37 to simplify कर सकते हैं, वो करेंगे, But how do I get the direction right? So for the direction, this is my suggestion. You look at the original vector. एक तो मतलब तुम वैसा triangle law से you can get the directions as well. But one of the easiest ways is look at the original vector and ask yourself, vertically वो vector ऊपर जा रहा है या नीचे जा रहा है? क्या लग रहा है देखने पे? Vertically ये जो vector है, vertically we can see that this is going up. You know, if you are talking in north, south, east, west, you'll say this vector is moving northwards as well. Right? So it's going up, it's going towards the north. So this direction, in that sense, has to be upward. The vertical part, the vertical component has to be upward. That's how I draw this arrow. And by drawing that arrow, I suddenly realize that this green vector, this green part is along J cap, because upward is positive y. So this green vector is along J cap. So this entire green vector becomes 10 Newton cos 37 J cap. When I put in the value of cos 37 as 4 by 5, it simplifies to 10 into 4 by 5, 8 Newton J cap. So my green part is 8 Newton J cap. About my pink part, for this I'll need to ask the question, is the horizontal part of this vector towards right or towards left? So when you again step back and look at the vector, is it ultimately going towards the right or is it going towards the left? By moving in this direction, you can sense that it is in a way moving towards the right. You can feel it's going towards the right. Right? So the horizontal part of this vector should be towards the right. So the arrowhead for the horizontal part is going to be pointing towards right, which makes this part point along the positive x-axis, and thereby this part is going to be 10 Newton sine 37 positive I cap. And we can simplify that by putting in the value of sine 37 as 3 by 5, giving us 6 Newton I cap. So now, I think I've just revised the values for you over there. Sine 37 is 3 by 5, cos 37 is 4 by 5. You have to memorize that. But now, A bar is made up of the pink vector and the green vector. The pink horizontal vector is, in a very simple way, written as 6 Newton I cap. And the green vertical vector is written as 8 Newton J cap. So A bar all of a sudden can now be written in this form. Okay, it can be written in this form. This is how we represent this. Okay, so I have done this example. I'm going to give you guys now some examples to try. In fact, as you're copying this, you can maybe try this. Okay, 5 Newton. This is my vector A bar. Okay, and it makes an angle of 30 degrees. Okay, with this leftward direction. And I'm going to ask you to write in express in write A bar in terms of I cap and J cap. And something is incomplete in this question. What can you identify? What is incomplete? What is not making this a good question? Very nice. Yeah, this is, you may see this sometimes, है ना, कि बंदे ने सवाल पूछा है, उसने एक्सिस डिफाइन नहीं किया है, तो just forgive him and assume these as your standard axis, but that will not qualify as a good question. He should always define the axis. He should always define the axis. So now this is a good question. When I'm asking you to write in terms of I and J, I'm telling you right is X, up is Y. attempt this example. सही है कायनात, very nice. Yeah, so you can actually be that quick eventually. Of course, if you're doing this for the first time, थोड़ा time लगेगा कि reach सही है. But if you have had a little practice, उतना जल्दी हो सकता है. Yes, Bhavya. एक सेकंड. वरुण सही है, गुड. ठीक है, राइट. न्यूटन एज वेल, बट या सही है. भव्या सही है. Where did that go? अच्छा, sorry. स्मृति रूपा सही है. सानिया yes, also multiply that with 5. प्रणव you're right, but then which is which, है ना. तो थोड़ा इसमें थोड़ा और कुछ करना है उसके साथ. Okay, so let me now just show this, and then since we're almost out of time, so what we're going to do is ये जो अपना न्यूटन ऐसा at some है ना weird 30 degrees with left. ठीक है, so 5 Newton is making an angle of 30 degrees with left. This is my axis, है ना. And of course, in case you forgot, sine 30 is half, cos 30 is root 3 by 2. Don't mess those up. But now what we'll do is, first thing is I'll draw ऐसा एक vertical and horizontal part. ठीक है, first I'll just draw them. I won't give it any direction. तो मैंने बस light green and pink वाला line draw किया. उसके बाद मैं पहले मैग्नीट्यूड लिखूंगा. तो आई से कि जो 30 के बगल में है वो हो जाएगा हाइपोटेनस cos 30. तो ये हो गया 5 न्यूटन cos 30. यहाँ पे cos 30 का वैल्यू डाल देंगे. cos 30 is root 3 by 2. तो ये हो जाएगा 5 root 3 by 2 न्यूटन या 2.5 root 3. फिर हम बोलेंगे ऑपोजिट वाला, ऑपोजिट 30 is 5 न्यूटन sin 30. ठीक है, ऑपोजिट 30 is 5 न्यूटन sin 30. Opposite is hypotenuse sin 30. Sin 30 is half, so that becomes 5 Newton by 2. Yeah, 2.5 Newton. So now you have the values ready. Now you want the directions. So go back to this, ask yourself, is this vector going towards the left or is it going towards the right? It's going, if you analyze it, you get the feeling that this is moving towards the left. So when I draw the arrowhead on the horizontal guy, I will draw the arrowhead pointing towards left. Now pointing towards left means this part is opposite my x-axis. So this part gets the direction minus I cap. Magnitude itna hai, direction hai minus I cap. Okay. So my horizontal part is 5 root 3 Newton by 2 minus I cap. What about the vertical direction? Is this vector ultimately going up or going down? Clearly it's going up. So because it's going up vertically, this is upward. And if you look at the upward direction, you'll see that's exactly positive y. So therefore, this gets the label positive j cap. Okay, so this vertical vector is 5 Newton by 2 positive j cap. So what is our conclusion? A bar has been written in terms of these two vectors, but 5 root 3 by 2 Newton opposite x is minus 5 root 3 by 2 I cap. So that's what we did some 2-3 pages ago. And 5 by 2 Newton upward is positive 5 by 2 j cap. Positive 5 by 2 j cap. Got it? Any doubts in this? Okay, cool. So we'll stop here. Um, yeah, I'll give you some sums for practice. So okay, I'll give you some sums for practice. Just remember the names. So in the sums, I'll give it in this form. I'll say कि convert from one form to another. तो उसके लिए बस नाम याद करो. I'll go over the names. Homework from booklets I'll give tomorrow. We're still in the middle of something. But ये जो conversion के लिए थोड़ा practice दूंगा. Just remember the name. ये जो जब इस form में लिखते हैं ना, इसको बोलते हैं coordinate form. आई कैप जे कैप के फॉर्म में जब लिखेंगे उसको बोलेंगे कोऑर्डिनेट फॉर्म. और जब ऐसा लिखेंगे मैग्नीट्यूड एंड एंगल तो उसको बोलेंगे पोलर फॉर्म. ओके, so these are the two names. Polar form is when magnitude and angle is given. Coordinate form is when it is written in terms of x, y, and z components. For now, we're just working with x and y. So this is coordinate form. This is polar form. So your homework will be कार्टेशियन एक्स वाई कोऑर्डिनेट्स के टर्म्स में जो लिखोगे दैट इज कॉल्ड एज कोऑर्डिनेट फॉर्म. सो योर होमवर्क विल बी आई विल गिव यू अ वेक्टर लाइक दिस. आई विल से convert it to coordinate form, convert from polar form to coordinate form. So I'll say write it in terms of I cap and J cap. That's what it will mean. Okay, cool. So I'll send you that on the group. Okay, bye. Welcome.